Good morning, students. Today we're going to do the video on the use of the brake lathe. This is something that I already did as a demonstration in person. However, this is something that does require quite a bit of practice for most students to get familiar with the controls of the machine and using the machine. So this is going to be a how-to or an instructional video on how to use this machine properly. And these are the things and the guidelines that you're going to follow in practicing this machine. So it's right behind me here, and it is an off-the-car brake lathe. And this is a very common tool. This one is red in color, but usually they're going to be blue in color. This one is a Snap-on brand, but Snap-on doesn't make this piece of equipment. They've just branded it with their name. This is made by other companies, and they're very, very common. Most of them are very, very similar. So the operations and controls on almost all of them are going to be the same. So walking through step by step, we've already got a rotor mounted on the machine, but I'm going to show you how you would do that as well. So the very first thing that you would do is you would take your rotor, and you're going to have to choose the appropriate adapter. So these are a set of cone adapters that would go inside of the hub area of the rotor. So you have to find one of these that is appropriately sized, that is going to fit your rotor. So you don't want it to fall through the rotor, and you also don't want it to be so big that it's just barely inside the rotor. You want it to try and be halfway approximately into that hole of that rotor. You also want to make sure that it's clean. These things get metal shavings on them, and you just wipe them off with a towel. So we've already got one mounted, so there's no need for us to choose this adapter because it's already on there. Okay, so moving up to the machine, we've got several different functions here. So first, we've got our toggle switch, and our toggle switch is going to actually turn the machine on. So we flip it up to engage the power, and then the rotor is going to begin to spin. Now before we get started, we want to make sure that that rotor is spinning true and spinning straight. So if it's wobbling around, you need to turn the machine back off, and you need to correct that issue. And we've got our feed control. So this knob right here is going to control our feed speed, and this machine is preset for cutting rotors. It has two speeds, fast and slow. So anytime that you are going to be machining a rotor, generally you're going to do your fast cut first. You want to take material off the rotor as quickly as possible so that you can speed this process up, and then you'll finalize with a slow cut. So in order to make a cut, we are first going to get this positioned correctly, and it's already in place, and we are going to turn our knob here clockwise, and it's going to run the cutting head up against that rotor. Okay, so we can hear it making contact. I'm going to back this off. Now these knobs are set up just like a micrometer. We have these numbers and these readings. So we are always going to start off on the 0. Each one of these lines represents 2/1000ths of an inch. When you're using this machine, you want to make sure that you do not exceed 2 lines or 2 notches at a time. And the reason for that is conserving the life of our tool bit. Those tool bits get extremely hot. The more material you take off, the shorter their lifespan is. So in a school setting especially, we don't want to wear our tool bits out. So what we're going to do is we are going to make sure we turn the knob out here. If you turn the knob here, you're not really turning anything. This turns independently. So we are going to turn this until we hear it make contact. Just like that. Then we're going to lock our knob down. Same thing over here. Lock the knob down. Okay, so from this point, we're going to turn our dial to 0. And we got 2 zeros. We got a metric 0, which measures millimeters, and we've got a standard 0. I always like to use the standard measurement. Okay, so we want to try and keep this the same on both sides. So we are going to run this in. Now when you're running this in, you've got to be careful. You do not want to let the cutting head come into contact or crash with the hat part of the rotor, which is right here. So you've got to be cautious when you're doing that. This is a machine that requires you to pay close attention to what you're doing. Now, if this rotor had not yet been cut, this is the same one that was on here the other day, we would have actually ran it out first by hand to cut the rusty edge off the rotor, but there's not a need to do it for this particular video because everybody already saw me do that. So now, we're going to take this loose right here, and we're going to go 2 notches, and remember you turn it on the outside, do not turn it on the inside. So we are going to turn it 2 notches, which is a total of 4/1000ths of an inch. So we're going to go 1, 2, and then we're going to lock it down. Same thing on this side. 2 notches. 1, 2, lock it down. And then we're going to do a fast cut first. So fast, we are going to lift up on this knob, up, and then we're going to pull it towards us. So we're going to pick up and come towards us. And then we're going to let the knob go. And the machine is going to begin the cut. And you can actually watch the cut process. You will see if the rotor has high and low places on the rotor as it's cutting. Okay, so here's our automated feed. You want to make sure that you stand clear of all the rotating parts of the machine. And we can actually watch it make that cut. So this rotor's been machined before. It doesn't have any high or low places. This is just for demonstrational purposes. About 50% done with that first cut. Okay, and you can hear it actually stop cutting. Now this machine is partially automated, so you can see it's still going even though it's not making the cut. And in a real world environment, you wouldn't stand here and watch this rotor. You would be working on the opposite side of the vehicle, getting that rotor off and prepared to put on this machine. So if this machine continues to go, it has a stop point. So it will actually come all the way off of its gear that engages it, and then we would have to re-engage it. So it's not a big deal if that happens. When we are done making our cut, we're going to put the machine back in neutral. So we're going to lift up on this knob, put it back in the middle, and then we're going to turn the machine off, and we're going to examine our rotor. So if the rotor still has dark places on it, that would indicate a low spot where it had not actually touched the cutting head. And that would mean that we would need to go back and we would need to make another fast cut. Sometimes rotors will actually only cut if it's a really bad rotor that has a lot of variation or a lot of thickness variation. It might only cut 50%. So you might have half of the rotor looking like this, and then the other half of the rotor still be dark and unfinished where it hadn't made contact with it. If that's the case, you go back and you make another fast cut, so you go in 2 more notches. Now if it looks like this one, if we can clean it all up on the first cut, that means that the rotor didn't have hardly any thickness variation, maybe just 1 or 2 thousandths. And then we're going to finish this up with a slow cut. Now on a slow cut, all we're trying to do is we're trying to basically finish or polish up the surface of that rotor. So if we look back at our knobs, we can keep track of how much we took off. So we took 4 thousandths and 4 thousandths. 4 plus 4 is 8. So we removed 8 thousandths of an inch from this rotor on this first pass. On the slow cut, we don't want to take off any more than we really need. So we might go just 1 more notch. So we would run this machine back in. We would go all the way back to the start process. We would unlock our knobs. We would go 1 notch, which would be an additional 2 thousandths of an inch. We would lock our knobs back down. To do a slow cut, it's going to turn the machine half the speed that it was on the fast cut. So we pick the knob up and we go towards the wall. And then we would walk away and allow it to do its cut. And that's going to put a very nice finish on the rotor. So at that point, we would have 3 notches on each side, which would be a total of 6 thousandths on each side for a total of 12 thousandths on the rotor as a whole. Now, in order to do all this, it's important that you understand when you're cutting this material off the rotor, you have to also ensure that you're not making the rotor too thin. So that's the importance of measuring that rotor before you start this process. So you would measure your rotor first, and then you would compare that measurement with the minimum thickness specification that the manufacturer specifies. They say that the rotor can be this thin. So if you're very close to that tolerance already, and you take 10 or 12 or 15 thousandths of an inch off the rotor, you could very easily undercut the rotor. And if that's the case, you can't put it back on the car. So you got to make sure that you're within that tolerance or within that specification, and that you're still above that specification before you put it back on the car. If you have a rotor that is already marginally in the area where it's going to be too thin, the only option you have is to either A, put it back on the vehicle and not do anything with it, or B, buy a set of rotors, buy a pair of rotors. You cannot machine a rotor and make it too thin. It's dangerous. It leads to brake fade, which is very, very bad in the event of an accident. So machining a brake rotor, as you saw here, is not hard, but it does require you to remember which way to turn these knobs, how much to turn these knobs. Do you do fast or slow first? So it's just a process that you become familiar with when you practice this over and over and over again. Generally, it takes the average student 3 or 4 tries at doing this before they can really do it 100% on their own. So the purpose and intent of this video is, right now during NTI, you can watch this video as many times as you need in order to hopefully grasp all the little details of using this machine. In a normal in-person situation, students would come out here. I would do a live demonstration just like I did on Monday, and then I would allow students to come out here Tuesday, Wednesday, Thursday, Friday, and they would take turns in small groups, pairs, using this piece of equipment. And we would do that until every single student had gotten through it. And then we would repeat that process again as many times as required for students to get a handle on it. We can't do that at this time, so I'm hoping that this video will help students get some virtual practice. This is a task that I require all students to demonstrate. There are a certain number of things in the automotive program where students are required to demonstrate on what I refer to as a hands-on assessment. So, in other words, the goal or the purpose of a student practicing this is they need to be able to show me the performance aspect where I bring them out here and I instruct them to make either a fast or a slow cut. And they have to be able to turn the machine on, turn the knobs, and perform fast or slow, whichever one I tell them, 100% on their own. If they can do that, then that shows me that they have mastered that skill or that task. In addition to that, they also have to measure the rotor with a micrometer and compare it with that minimum thickness specification. They have to make the determination. Is the rotor acceptable to put back on the car, or do we need to discard it? So if they can make that determination, that really tells me that they 100% understand, number one, how to read a micrometer, and number two, what the number represents. Reading the tool is important, but knowing what that number actually means is the most important thing. If you can read the number but you don't fully understand what you're actually reading, then you're not really 100% proficient in that area. So that is the goal or the purpose of this assessment. I hope that this has been informative for students, and hopefully in the very near future we get to come back and do this in person. And if not, then we'll do the best that we can. I hope everybody has a good day, and if you have any questions about this video or about the brake lathe or about micrometer reading, please contact me. There will be an additional video made on micrometer reading for students as well, and it will be put out shortly after this one. So have a good rest of your day, students.